rotated thing, the goal here is to take this information and turn it into like a crop of this that is like perfectly axis aligned. That's the goal here. So what do we have? We have a bunch of pixels here where we know that their gradient all lines up in like some way, right? And so that should give us like if our barcode is like this. Eliante, thank you for the gifties. Thank you. 10 gifted. Very kind. Very kind. Yeah, so if the barcode is aligned this way, we should have a gradient that goes like this way. And so this gives us like the x-axis of our image, right? This arrow is x, which means that this is y. And then we just have to find like center and a width and a height that like match the points in the box. That is the plan. That is the plan. So how do we do that? I don't know yet. We'll see. I guess we like take all of the points and convert them into their locations. We take all the points and average them, probably. Is the average... So if you have like a rectangle, with a center, and you rotate it, I don't really know if like the center point is like the same. Of course, the center is the same because you're rotating around the center, but like, is it true that there's the same amount of pixels to the left and to the right? It's gotta be, right? It has to be. It's symmetric. It has to be. So we find the center. Okay, sure. No, fuck. I'm not convinced. Yeah, because I think anything that moves on the right is mirrored by a thing that moves on the like up the top. I think it's true. And if it's not true, then like maybe it's fine anyways. So maybe we just find a center. Maybe it sounds reasonable as long as it's convex. Yeah. I'm making an assumption that that these things like kind of represent a rectangle in some way. I guess the better answer is maybe though. It might make more sense to convert every sample into like our coordinate space, our like rotated coordinate space first, right? And then just like center it based off the maximums, like the minimum and maximum. The problem though is that you need like a center for your coordinate space, right? Like if we rotate everything, yeah, it's only symmetrical if two cases are true. It's not for those oddly shaped ones. Extended height. Yeah. Makes sense. I mean, I guess we can just pick an arbitrary point in the picture as an initial center. Rotate each point around that thing, right? So like we have in our example like this, right? Something like this. Then we can like just use the center of the picture or something. Take like rotate this thing for each point that we find, you know. Rotate around the center, right? So then this little thing will be kind of like this after rotation, right? Rotate around the center such that like this is our new x-axis. Then once we have that, then we can find the minimum and maximum x and y values in this space, right? Isn't a barcode usually found by having a lot of neighboring high contrast edges being detected? Or did I already get that? Yeah, so that's what we've done here, is we resize down, we do edge detection on like a small image-ish, we like downsample the gradients, and we like kind of look for pixels that are surrounded by other pixels that have like a similar gradient, right? So like high contrast edges that line up, right? And now we're trying to say, okay, now let's like extract that somewhere. Yeah, I think that this approach works. Initially I was going to say like average all the pixels. Why rotate before extracting the barcode itself? Because we need to find a center position. That center position is kind of like done by looking at every single pixel, or every single sample, I should say, right? In this cluster. And we don't want to have to look at that. Like, if we're going to guess wrong for a center, like, how do I say this? Okay, so we are going to look for the minimum and maximum x values, but the x values are like in rotated space, right? We want like the maximum new x. And so like we need to do a rotation to like find a min and max. And how do I say this? So you just need like a center point to rotate around to do that. Most have a fixed aspect ratio. Just looking around my house, I can guarantee like they're not fixed. They're like very variable. Just like looking at stuff in my house. Some of them are skinny, some of them are tall. So I think that's not it. You should like there is like a guaranteed white area around which we could leverage in some way, but I think that we'll do that as like the first pass of the next step. So I think like step 1 is like find things that might be barcodes. Then step 2 is like check if those things are actually barcodes. That's kind of what I'm thinking right now. Did you do the gradient folding? What did you end up doing? I think I ended up just doing whatever we were doing last time. Like, we built a map of all pixels that are, sorry. For each pixel, we like add to a cluster him and all of his neighboring pixels that have a similar direction. And then if we run into like guys that already have a cluster ID, we just like iterate them, all the guys in the other cluster, and like reset them. Whatever we were doing before, but we do it on like a smaller image now. That's how we fix like the optimization problems from last stream. Okay. Focus. Let's focus. We gotta find minimax x. So I wonder if we can start by we need a list. Why is this thing? We need a list of all of the pixels per cluster, right? So right now, our output of the clustering step is an image where each pixel has like a cluster ID on him. This thing just needs to also return like the whatever internal data structure he was using to build this thing. So we have somewhere a hash map of cluster ID to 2D point. So I think we just need to expose this as part of our output. So this should be like, you know, map. I don't know. usize to cluster point. Something like this, right? And we just need to make sure that when we're done with this guy, we're removing things that are not being used. Hype, okay. The argument that you made about being symmetric means you can rotate around the center of the bounding box. We don't have the bounding box yet. We're trying to make the bounding box. Right? And so, like, if we're going to be looking at every single pixel, we might as well be looking at every single pixel in the correct space. Right? Because we're trying to build the box in rotated space, which means we have to unrotate it to find the min-max. Or you find the... Yeah, you need, like... To, like, have, like, a center point, you have to, like, take the average of all the pixels or something. So I think that this makes sense. I think we're just gonna like, yeah, we'll see. It'll come together. it'll come together. So I think all we have to do here is return the map of cluster list. And can we just make sure that like the output of this thing is not shit? If we're just like count. Std debug print cluster count. Yeah, let's do this. Cluster count 2. Okay, so we do have 2 potential clusters, 2 potential barcodes, so that is correct. Which means that this map is probably right. Can we also go like, also, let's do a quick smiley commit just in case. For, you know, cluster results map iterator, I guess. While it next, let's look at some entry and just make sure that like the sizes of the number of points in each of these also look same. Cluster has this many points. I see, I didn't realize you only had the bitmap format. Fair enough. Yeah, it makes sense. Makes sense. Same amount of work in different orders doesn't really matter. That's exactly what I'm thinking. Exactly. So this thing has 115 and 238, and if we just kind of like drop these down, it looks like the number here is kind of respecting the change, right? It says like, so it means that like we're properly tracking this map, as far as I can tell. As far as I can tell. So all that to say that we should just be able to like iterate over clusters and do something with them. It makes it also seem like that this thing is going to return actually a list of images from this guy, right? Because we're going to have like multiple potential answers. So I think we only care about, honestly, like we don't care about cluster IDs anymore, I don't think. And we're gonna just call this like, you know, ret here is an array list of images. Okay. And for each of these guys, I guess here we know exactly how large this is going to be too, actually. Because it comes out of the cluster results map count. Yes. Yep. Okay. So this is just going to be like return ret items, boom. And for each of these guys, we're going to be like ret.append. It's like image, like cluster to image. Yeah. Yeah. We might have lost. We also need the image itself, the cluster image itself, I think. No, the gradient. We need to use, because the gradients here are how we're going to determine the x-axis of each of these things. Right? Okay, sure. So cluster to image is almost certainly something that can fail, because there's almost certainly going to be some allocations in here. I don't really know. Maybe not. I guess we'll see. Oh yeah, because it has to make an image. Yeah, so obviously this thing will allocate because it needs to allocate an image. Okay. Maybe this thing Does it always? Yeah, it must always. What are we making? Barcode scanner. Barcode scanner. Oops. I actually want this here. So this is Alec, small gradient, and entry. Okay, so what are the parameters here? It is a gradient, which is image of vec2s. Yep. And points is a hash map, a hash set, which is just a hash map in this language of cluster point. Okay. Okay. Cool. I guess this is technically a pointer to this thing. And this thing can fail. Okay. Okay, so what are we going to do here? We're going to iterate over all points. And for each point, we're going to extract the gradient direction. We need to find the x-axis for this thing, right? So find x-axis is we're going to turn a vector 2, I think. And we're going to use these guys. Boom. Okay, so maybe we do this first. Find like x-axis of this thing is something. Find x-axis given the gradient and the points. And then we print this thing. Okay. Yeah. Okay. So for each point in here, we go like we look at the gradient at point x, point y. And I think we can just average this. I think. I don't know, we'll see. Because these guys are now like 2D vectors. And so I think that if we average them out, they should just turn into like a reasonable end vector, I think. And then we should just be able to be like total normalize or normalize this vector. Yeah, should be. Should be. Yeah, can we ignore this for a second? It's fine. Okay. So on one of these guys, the x-axis is like almost totally vertical, which is probably this one, right? You're seeing here that there's like a lot of like flickering in here. The other one is, oh shit. We might have to invert some. Yeah, because they're in opposite directions. So when we average, they're gonna like come out to 0. So how do we make sure that that's not the case? Yeah, so you have like 1, 0, negative 1, 0. If it's like that, you just flip over y, right? But that's not really that helpful because like they might be like this. And if they're like on an angle, you know, like you almost want to check like I guess you can just compare with the total and flip if it's negative. If the dot product is negative. I think. Because like say your opposite directions vertically or like horizontally. um, you can't just like compare if like y is negative or something, right? Because then this case doesn't really get handled correctly, and you can't like do if x is negative because like then everything will kind of flip into this area, which means that you are losing something there. So yeah, I think that you just dot product with the total and flip. I think. Mod 180? No, I think that mod 180 doesn't work because this case is like correct. Like how do I say this? These guys are like similar in terms of like axis direction. Somewhat similar, not perfectly similar, but somewhat similar. Right? This is only off by like this many degrees. But if you but it looks way fucking worse in this scenario. So what I want to do is I want to say like, hey, if this guy is pointing like over this line, flip him back. So then he would point this way, and then we would get this angle instead. You know what I mean? I think that works better. So we get the total, and we say like, if we do like the dot product of the total and point. Where the fuck is this rotating around? Top left of the entire image, which is like fine. That's like a place to rotate around, sure. Oh no, this is gradient direction. Never mind. This is this is fine. If this is negative, it's like this gradient is the gradient we extracted. And then if it's negative, this grad equals negative this grad. Just flip it completely. I feel like that's right. I guess maybe this doesn't work this way. Maybe we have to do like this. Oh, fine. Oh, okay. Why is he mad here? Oh, this is wrong. This gradient here. Oopsies. Oopsies. That was close. Okay. So now this guy, his x-axis is negative 0.76, negative 0.64. Which I guess is like fairly vertical. Like, sorry. 3/4 horizontal. It's like just a little bit tilted down to the left. No. Which way is y up? Up. Up is positive, it should be. So this is like pointing down and to the left, or down and to the right. This one's down and to the left, which is probably this guy. This one's down and to the right. Can we log their cluster sizes as well? That'll help. That'll help us identify which is which. That will help. That will help. Okay, so the bigger one should be ours. Yeah, okay. So now we only have one, and he is going... I'm concerned. This doesn't look right to me. Because he's going negative, negative. Which is like pointing down to the left, which is like not what I think this should be. Especially... Okay, can we start... Let's, work with a horizontal one first. Okay, so this is working, right? This is almost completely horizontal. And then can we like do like a very, very, very slight rotation just to like get a feel? Very slight rotation. So here, he is still like extremely horizontal, no? Like extremely horizontal, like more so than I feel like he should be, given this image, which is concerning. Ah, but you can see there's like aliasing here, right? Which could be causing issues, right? There's like vertical scan lines here, right? Which aren't in the original. So I wonder if this fixes itself if we kind of like increase the resolution till those kind of go away. Okay. Yeah, that's interesting. So now this is right, and we have to be like very, very careful about this. Is this a personal project? Yeah. Yeah. Fuck. Okay, I didn't consider that at all. So this is because our initial resize method is sampling instead of averaging, I think. So I think that we might be able to fix this like aliasing issue if we do like a better resize function. So for now, let's pretend that this isn't a problem. Okay, so we'll just like crank this guy back up to say we'll do edge detection at like relatively high resolution, like maybe 512 width. Then we will just downsample more before doing clustering. And we'll kind of call that for now. So this is downsample 6, target width 512. I guess really, like, if we're doubling the size here, we only have to double the downsample factor to be the same. How's that look? How does that look? Okay, no aliasing. There we go. Hype. Okay. Let's work on this image, and then we'll come back to this later. Maybe we won't. If it's fast enough, maybe it's fine. Oh, wait, I forgot to check the values of the... Yeah, okay. So now he thinks that it's, like, a little rotated, which I think is true. And then let's, like, crank it a little more. So now we're cranking to, like, 45 degrees-ish? Right? Ish? You know, we're playing it fast and loose. Again, though, it being negative here is, like, so... It feels so wrong. Was that when I had it like a little bit rotated like this? It was positive. So it feels like y-axis is flipped here. It feels like it's like doing the right thing, but the axis is not what I expect. How? So we know from the colors of the pictures that the x-axis is red, y-axis is green, right? So like these gradients are, in my mind, like correct, right? Green lines are pointing vertically. But I guess we don't know. We don't know which way is up on the y-axis gradient. Oh, it could be here. Our vertical gradient kernel, if these are flipped, like the direction which we consider negative and positive, here we have positive is right. Here we have positive is down. Oh, my dumbass. Bigger numbers y. Yeah, I want this to be this way. I want it to be so that up is up. So if we're considering this right, then this has to be considered up. This way. So I think that should fix it without any like other really noticeable consequence. There we go, right? So now this guy's seeing negative y, positive x, pointing down to the right. That's great. That's great. Cool. So is that our gradients, we had nothing in our visualization showing which way they were going, but we kind of like flipped the order of black to white and white to black on vertical and horizontal. But now we're good. Okay, so we have like an x direction, which, as far as we can tell, relatively correct. So for each point here, we should be able to be like, okay, so we have like x-axis is find x-axis of gradient and points. For each point, so this is our second iteration over our points. We rotate it around. Okay. So we have 0 zeros here. If we say our x is like this, coming out of 0, 0, and we have a point that is like here. You know, he has like some x and y values. How do we find his x position here? It's just that we have this now. Okay. So that means that you have like these angles from horizontal, or I guess like, yeah. So it's like we want to do like this vector. This vector is composed of this and this vector, right? Our new x-axis and our new y-axis. And we determine those by saying, this is just like a rotation matrix, right? Yeah. Something like that. So it's like, okay, I have to draw it less like extreme for me to understand it. So we have old value here's the image. say our new x-axis, we're rotating just a teeny tiny bit up to the left. Or like, this way. It means that if this point is like here, right? 0, this is like, what, like 10, 0, right? As like a pixel position. It means relative to this coordinate system, this should be like 9, 1 or something. Right? Because it's actually like, yeah, because he's below this x-axis. Yes. Which means that his x value is the cosine of this angle, gives us this, and sine of that angle gives him the y position. Yes. Yes. Okay. Okay, yep. Now, when we are eventually trying to find the center position, I don't know what that's going to mean. But we'll figure that out. Okay. So our y-axis is looking at this picture. It's vec2 with our x. So here our x is small and positive. Here our x is small and, or our y is small and positive. Here our x is small and negative. So this is like negative. Dude, my brain. Negative x-axis 1, and this is x-axis 0. Okay, here are x and y axes. You already have the center position? Oh yeah, I guess because we have to do an iteration to find the x-axis, we might as well find the center of the box here. I agree. Find x-axis and center. Not sure I agree. Because that's like center of mass, which is different than bounding box center. Yeah, not convinced. We'll try this and we'll see what happens. We'll try. Now, also, pixel positions here grow this way. So we might want to invert our y here. Inverting y because pixels grow down. I think that makes sense, but I don't fucking know, man. It might not matter. Okay. So now we have like the cosine is a dot b. We need to like normalize this. This is normalized, so this is normalized, which means I think we do like math of x-axis. We dot product the x-axis with point. So we can do like point v2. We need to get this to be the right type. Point x, point y. If we dot product these, this is a times b times cos theta between the two things. the x-axis length is 1. So now we have a times cos theta, which is the length of the line to the point projected onto the new x-axis. Yeah, so I think that this just gives us like new x. And new y is just doing this on the y-axis. Hold on. So we have like we have a point here. So if we project this onto the y-axis, yeah. Project this onto y, project this onto x. This value and this value. Yep, yeah. I think that's right. I think that is right. We'll fucking see. Okay. So what do we do with this? Min new x as a F32, I guess, is I don't know. Float max. Max new x starts as negative float max, and then we do the same thing for y. Okay. Min new x is equal to the min of new x and min new x. Max new x is max here. And then we do the same thing with y. Okay. And then from here, we have this, we should be able to have the center width and height, right? So the center x is min new x plus max new x over 2, right? Center y is y. And then the width is max new x minus min new x. And height is new y minus new y. Okay? And now this is actually in like rotated space though. So we just on-rotate. So it actually doesn't fucking matter if this is inverted or not, I don't think. Because if we just undo the rotation to go back, then we're chilling. So if we have a rotation that starts by having our like this, to rotate back, so this is like x, y. How do we go back? Forgot to change min to max, true. How do I go back here? I guess it's like something to do with like invert the angle of new x to x. Yeah. So you have like a x-axis. Yeah. There's something here. Something here. I just don't know what it is. Dude, my poor stupid little brain. Okay, can we at least log this stuff for a second? Width and height. Is this part correct? Before we start getting too far down the fucking rabbit hole. Can we do this as like calc box params? for now. Okay. Calc box params, gradient, and entry. Something like this. Something like this. Fuck. What is he pissed about? IT next. Oh. While, not for. My bad. My bad. What do you need the center in original rotated space for? For like extraction, I think. I could be wrong. I want to draw the box like on top of the image, which I think is important here. I think. I don't know though. I don't know. I feel like it's required to draw it. Okay, width 34, height 34. How big do I think this is? If I downsample more, it might be easier to like. So width 14. 1, 2, 3, 4, 5, 6, 7, 8. That's not helpful. I guess height here. I'm trying to like use my fingers to like look at if I think that this height is like correct. I guess we could also look at like the min maxes. That might be interesting information. Min x, max x. I think we do y's here. Something about this doesn't feel right, huh? So here we have min x 38, max x 72. Min y, max y. Can we look at them before as well? And then old x is float from int point v2. Old y is like. All right. Does this give us information? Old. What was this guy pissed about? Oh yeah. My bad. Wrong type. Put a dot or something in those occasions. Yeah, not crazy. Not crazy. I think it's like not super trivial to draw right now, but okay. So old x is 52 to 86, right? So that's kind of like these. Old y is like 22 to 53. Then when we rotate this stuff like up, you would think that the x's would grow. Or like the min x would grow because he's rotating around like 0, 0. Right? Min x. Because we're pointing. This has to get flipped. It feels like it has to. Yeah, there's like something fucked up here where our points, because like the y grows down, but we're treating our y axis as up. Like there's something fucked up here. I can't really place it, but I'm just gonna like negate y here. Because I feel like that's right. But I can't really like justify it that well. It just feels like these coordinate spaces are fucking with me. Fine. Fucking coordinate spaces, man. Okay, so now min x. Yeah. So old min x 50 here. Then as we rotate it like up this way, then the new minimum x grows, right? Which makes sense because this has like rotated up. So that makes sense. Old max should shrink, right? Because this part, this like corner sticking out to the right should kind of like dart in as like, can we cool hang this, bro? Yeah. Right, because like this is gonna come like up like this, and this is gonna come down like this. So it makes sense that the min and max should kind of like come inwards, right? So that makes sense. Now what about y? Before we had min y as this is negative 24 and this is negative 53. Now, what are we expecting? We're expecting this to come down. Well, all of this is actually rotating around like something like way over here, right? So we're expecting all of this to come up like this, which means that all of these numbers should grow. So that's correct, right? This negative 24 turns into negative 5, this negative 53 turns into negative 27, and the difference between these, we expect this to kind of go down from this distance, right? From this, it should kind of like turn into like effectively this distance, right? So does that happen? Min y, so before it was like, oh, sorry, this is, before it was like approximately 30 apart. And now it's approximately 22 apart. So I believe that that's right. I believe that's right. So that means that like our current rotation stuff, hand wavy, probably correct, right? Now we need to go back, right? We need to go back. So we have, right now, we have the x-axis in original space. We convert this to the new axis. So we need our old x-axis in new space. And that's how we go back. So x-axis new x x old x-axis in rotated space. That's what we're looking for, right? So this is like we rotate the point 0, 0. So this is so this is just x-axis 0. Y-axis 0? No. Hold on. Hold on. So we take... Okay, it's like this, right? So we take like a horizontal 1 0, dot that with the new x, which is essentially what we're doing down here. But this dot product turns into like something really obvious, right? This is just taking the first parameter of x and y. Okay. Okay, so old x new, we'll call it. Old x-axis in rotated space. And so we should be able to apply the center positions, you know, like center x new is max new x plus max new y over 2. Center y new. So old y new is old x new. Okay. So then we take like center x is we take the center x new and dot it with old x in new space. Okay, I mean, I'm not like 100% on this, but it feels like maybe. Feels like maybe. What's he pissed about here? Oh yeah, this is just, we need this. Okay. Okay. So what do we get? Center x, 39, center y, negative 18. So the question is that about right? Right? So if we have 60 to 92, oh, sorry, 52 to 86 is where these guys are in unrotated space. So this is just really fucking wrong. Yeah, this is wrong. Why? 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 Is it divided by 2 on the rotated rect? I don't think so. We've divided by 2 to get the center positions. So I think it should be fine. What am I doing wrong here? What am I doing wrong here? So, can we look at these values? Old, like, x-axis in rotated space should be old x new. Oh, I see what you're saying. This x should be a y. That's a really fucking good point. Thank you. Thank you. Would have taken me a while to notice. Are we inverting rotation matrices? Cool properties that inverses their transpose. Yeah, I guess we probably are. We're kind of just like doing rotation matrices shittily, I think is like what I'm doing right now. Okay, these could be right. Right? So the old, so 52 to 86. No, this is still 86, which is fucked. Yeah, it does seem like maybe you're right that we should just be doing this as like a proper rotation matrix, right? you're saying it's their transpose, which I think is actually where we ended up. I think. Where transpose is flip over identity, right? Matrix transpose 2 by 2. Rotation. I think. Yeah, flip over diagonal. Yeah, I think that's right. Right, because what I ended up doing was I took like the old. I took X, Y, and applied these here to the new X. So that means, yeah, that is what I ended up doing. That is what I ended up doing. Okay, first of all, so then what am I fucking doing that's stupid? These should be magnitude 1. New X, we were doing X-axis times the point. New Y, we were doing Y-axis times the point. So now we're just doing center Y times X in new space. I don't see anything like blatantly wrong here. Oh my god, you guys are so right. Dude, I fucked this up like 4 different ways. That's so funny. Good eye, good eye, good eye, good eye. Now is this right? Could be. 68 should be approximately halfway between 52 and 86. 14, 14, yeah. Old bin Y, so now negative 53 to negative 24. Negative 38, that also looks about right. Sick, thank you. So it looks like I think none of the hard math was wrong. It was all of the easy math where I just fucking calculated averages like hella wrong. These were just not averaging 2 points. Thank you. These numbers look relatively reasonable to me. Relatively reasonable. So, now what? We need to use these numbers to do something. So can we say that rotated box comes out of this thing, right? And we have center. Center, which is I guess like a vec2. We have width, height, and new X, I guess. Which is too many parameters, I understand that. But whatever. So here we say we don't need this like min old anymore. You know, this stuff isn't needed. And let's add a couple of comments here because I'm gonna get confused. So we'll say rotate point around top left corner of image such that the new x-axis is an x-axis. Invert y-axis as in pixel space, y is down, or y grows down. Okay. Project points onto new axes. Okay. Find min max in rotated space. Okay. Then find box params in rotated space, and then we'll say rotate back, rotate back, rotate the center position back so we know where it is in the initial image. Do we actually care about that? Maybe we actually just care about... Do we just more care about like the top left, like the four corners? Maybe that is more reasonable. How are we going to use these when we try to extract the image back, right? That's the question. We are going to iterate. We're going to like allocate image of width height, right? And we're going to like iterate pixel by pixel and source and like sample from original image, right? That's what we're going to be doing. So we need to know where that pixel is in the original, which I think is like... Sorry, I'm thinking. It's like center position plus... It's like if you have this picture that you're sourcing from here, right? You know that you are looking at center minus x by this much plus y by this much, which turns into a long rotated x along rotated y from the center in the original, right? So I think this representation makes sense, right? Where we store the center, width, height, and the new x, and maybe even the new y as well, right? Because we can use these just kind of directly like this as we sample. Linear interval between 4 points. Well, maybe. We'll get there. We'll get there. So I think it's fine here to just return. Yeah. Center x, center y. Width is width. Height is height. And new x is x-axis. New y is y-axis. Okay. Cool. So all we should have to do now... I don't think this can fail, by the way. I don't think there's anything in here that can go wrong. So box params is this. And so I guess here we create a new image from this thing. We have to undo the downsampling, probably. Can we do this? Downsample factor. Maybe we say like mul factor F32. So width is width times factor. Width and height grow with the factor. The center also grows. Okay. But the directions stay the same. Right? Because these should be normalized 0 to 1. Or sorry, these should be length 1 in any space. Okay. So this is downsampled box params. The box params is downsampled box params mul downsample factor. Okay. then we should be able to do like box params width and box params height. We need to like round these up. These are floating point right now. Can we do ceil and int from float on both of these? Okay, hype. This is like the output for this thing. And we use an allocator to do this. You know, unrotated is this. Okay. Hype. Now what? Now what? We go image iterator is unrotated iter. While we get the next pixel, we go x here. We minus the width over 2, I think. So like here, this is like 0, 0. If we're trying to find our offset from here, this is width here, so this is width over 2. Yes. So that's its offset from the center. Center offs x is this. New x. We multiply this by the new x-axis. Right, we say how much of this? This is not a dot product. This is just a straight multiply. And we have new y as well, presumably. Okay. So center offs is like okay, hold on. So we have this magnitude times this direction. Yes. So can we just do this? Yes. Image center offs image space is this. Center offs x image space. And the y image space is the same. New y. Okay. Seems good. I think we might need this. Okay. Nice. And then we take box params center plus yeah. Center offs x image space, center offs y image space, sample point. This is in float though. So then we say self resized image pixel at round sample point 0 int from float. Oh yeah. Yep. I think that might be right. That might be right. So we find our offset from the center, we convert that to image space, we offset from the center, which is already an image space, and we sample from the image. I think that's right. I think. So this, if it builds, hopefully at least it doesn't crash. That's a kind of like what we can hope for first. Sure. Sure, float from it here is fine. Okay, there's some X, there's some U's and some F's around. So this is as F32, float from int. Gross. Alright, let's try that. Fuck! What is he pissed about now? Oh yeah, I guess it's like this. We add the offset in image space in X and Y, because these offsets are like, they're like this and this. So these are like two vectors being added to the original center. Then are we chilling? Okay, he's mad because this thing's constant and he can't be. He needs to be variable. Okay. Crashing, which is no good. So what is happening here? What is happening here? It's like, that doesn't look good. That Y is, it's probably that like Y is negative. Probably. So sample point here. So can we std debug print here the sample? Oh, we can just like look at it in GDB actually. Yeah, sample point here. Oh. Y's are negative. Okay, so good news, nothing is crashing. And now all we should have to do is render these somewhere. So can we go to our GUI layout and just quickly huck in unrotated for now. This is going to be using the grayscale renderer. Like this. Okay, so now we can say, yo, we're going to show the unrotated version here. And then when we update this thing, we have to get the results here. Fuck. Okay, so now this is turning into something that should be a function. Okay, so we have image views here as an image views. Crazy. We got the extractor as a barcode extraction extractor. We also get in our allocator, scratch probably. Cool. Cool. So here we have scratch. We have actually more like this. Okay, and we have image. So this is the source image that we're updating from. Bing, bang, boom. This gets like the results. And this guy gets like results items 0 or something. Fuck it. I don't really give a shit right now. This is the out image, is image U8 or something. And then we have to update the output image. So it's like up unrotated, boom, 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 and the texture is like make a texture, an OpenGL texture from a grayscale thing using the out image data and out image width. All right. Cool. What does he want? He wants like the extractor and image probably. And this should be done here. Everywhere we do this stuff now, we have to update image views properly. Much nicer. Okay. Only 5.8 is mad because... Yeah, surely image views has to go in here, right? Wow, we just got the order of these like totally fucking wrong. Okay, almost there. What is this mad about? Found, oh. This was right. Okay. Try again. Please, God. All right. It's like this, actually. Okay, there we go. It builds. Let's take a peek, skis. Let's fucking go, dude. Let's fucking go. Let's fucking go, dude. Look at that shit. Look at that. That's a fucking extracted barcode. So we go from here. Okay, let's try rotating it a little bit more. And run it again. Okay. Look at this shit. Look at this shit. So we start with this guy. We resize him down. We do some edge detection. We blur the edge detection. We find places where there's like lineup of barcode. And then, oh, this is a bug. Hold on. That's not, this is easily fixable. It's that the GPU expects textures to be multiples of 8. Which I think you can just turn off. OpenGL allow non-multiple of 8 image texture. There's like some setting you can just fucking turn off. OpenGL set min texture, set texture width 8. I know there's like a fucking answer for this. I've done it before. I just can't remember what it is. In OpenGL, textures have to be multiples of 8 or else they warp. Is there a GL option I can set to allow multiples of 1 instead? Sky is not... Shut the fuck up, dude. Fucking asshole. This is not what I'm looking for. Pixel transfer parameters, if I remember correctly. Thank you. Dude, I fucking wish these, like, the whole point of these, like, fucking LLMs is to, like, fix this shit. Where I'm like, I don't know how to fucking Google what I'm looking for, but I know it exists. Help? And he's like, nah. Pixel pack alignment, I think is what I'm looking for. Pack alignment. Specifies the alignment requirements for the start of each pixel row in memory. The available values are 1, 2, 4, and 8. How do I set this? GL pixel store I assume? GL pixel store E pack alignment 1. Let's see if that fixes it. Nope. Maybe it was unpack alignment. There we go. There we go. Sick, baby. Yeah, so we're chilling, right? So we get this guy, resize, edge detect, downsample, isolate, extract, baby. Now, obviously, this is working off the wrong image, to be honest. This should be working off the original image here, not the resized one, but that's an easy fix. I just don't want to do it right now. I'm short on time, but I would say that's a pretty good success. We have to do some testing probably to figure out like how vertical this is. Like we might need to do some sort of like improvement on how we average out the cluster direction and stuff. But I'd say that's a win. Cool. Thanks for watching, guys. If you like what we saw, we stream most days. No one mentions upside down, and to fix we might need to digit detection parsing, rage bait. No. Oh, rabbit holes. I think I'll just try both. Because the left and right side of the barcode have different orders or something. I think there's something we can do to just try both orientations and then figure it out. But yeah, good point. Yeah, okay. We'll call it there. Thanks for watching, guys. If you like what we saw, we stream most days from 12:30 Pacific time to 4 o'clock Pacific time. It is 3:50 Pacific time now. So if you're watching live, anywhere between 3.5 hours ago and now is like when you should expect to see us live. We're working on this barcode detector as part of like a meal tracking, ingredient tracking website that we're working on. But there's a lot of other stuff in the backlog if you want to check out the YouTube, link to the Twitch description. If you're watching on YouTube, you might notice that the VOD is shorter than the mentioned 12:30 to 4. That's because we only post things that are like kind of like YouTube algorithm friendly, right? So if you want to support the stream and get access to the rest of the VODs, if you can't catch us live, you can support on Patreon, YouTube members, or Twitch, and you get the VOD access in whatever platform makes sense for you. Please consider supporting, right? This stream will stop happening when I run out of money and need to get a job. So if you like any contributions, like directly increase the livelihood or like the lifetime of the stream. So please consider, but obviously no pressure. I think that's it. Happy Sunday, YouTube, peace out, and Twitch, let's find someone to raid.